Alright, next up is finding an inverse. So to find an inverse, this is what we do. Yeah, I'm restarting this. A lot of things happened on the last video. So to find an inverse of a square matrix, remember square means the number of rows equal the number of columns, like this. Provided the inverse exists, if the inverse exists, what you do, you take a matrix A and you put the identity associated with that matrix. You do row operations to get the identity on the left. Whatever you have on the right will be the inverse of A. And that's how it works. So in this case, there is a formula for a 2 by 2. It's in the book. You could look it up. For practice purposes, I'm going to work this out. So you write the identity on the right for a 2 by 2. The goal is to make this side a 1 0 0 1. And how do you do that? The same way we've been doing the work. First, we need to make that a 0. So we let row 2 equal, take negative twice row 1 plus row 2. If I multiply row 1 by a negative 2, that's a negative 2, negative 4, negative 2, and a 0. If I add those, I'll get 0, 1, negative 2, 1. Now the next step is to make that a 0. Well, let row 1 equal negative 2 row 2 plus row 1. If I multiply row 2 by a negative 2, that's 0, negative 2, 4, and a negative 2. Add that to 1, 2, 1, 0. Row 2 I'm using, but I'm not changing. So since I have the identity for a 2 by 2 right there, that right there would be the inverse matrix of A. That's what you multiply A with on both sides and get the identity matrix. Now there is a shortcut in the book that says, given a matrix A, to find the inverse, that's 1 over the determinant. You switch those and you multiply those by a negative. You want to memorize that, you can. Make sure you memorize it accurately. That's only for a 2 by 2. For a 3 by 3 it's a bit more work, but not that much. So the way we start, we put on a 1 0 0 0 1 0 0 0 1. This takes a bit more steps, so you gotta be patient and work slowly. In our first step, we're gonna make that a 0 and that a 0. To do that, I'm gonna take, in my first step, negative 2 times row 1, add it to row 2, and that's the new row 2. And take row 3 and let that equal negative row 1 plus row 2. So if I do that first, multiplying row 1 I'm using, but I'm not changing. If I multiply row 1 by a negative 2, that's a negative 2 0, negative 4, negative 2 0 0. Add that to row 2. 0 2 negative 1 negative 2 1 0. Now the chances of making a mistake is very high, which is why you want to show me all your work to make sure that if you make a mistake, I could figure out where the mistake is and go from there. And if I multiply row 1 by a negative 1, that will be a negative 1 0 2 negative 1 0 0. Add it to 1 negative 1 0 0 0 1. That will be a 0 negative 1 2 negative 1, 0, 1. Alright, first step is done. Second step. I'd like to make this a 0, but I must do that by using those two rows. So the next level up, I'm gonna let row 3 equal 2 times row 3 plus row 2. So if I take 2 times row 3, that is a 0, negative 2, a 4, a negative 2, a 0, and a 2. Row 2 is right there. If I add those, what would I get? I will get, so this is the new row 3, add those, 0, 0, 3, negative 4, 1, 2, copy everything else. Alright. Now what? Now I want to make this a 0 and this a 0. And how can I do that? Any way I can. So to make those 0, first I could say, let me take, probably I should organize this better. The next problem I'll do is slightly different. It'll take longer, but probably the work will be easier to trace. I'm gonna take, so I'm gonna work this way, not down. I'm gonna take 3 times row 2 plus row 3, but put the result in row 2. Put the result in row 2. That will make that a 0. And I'm going to take row 1, allow it to be 2 times row 2 plus row 1. You could use any combination you want. Meaning, if I am to go ahead and multiply row 2 by 3, that would become a 0, 6, negative 3, negative 6, 3, 0. If I add it to row 3, and put the result in row 2. So that is 0, 6, 0, negative 10, 15, no, 4 and a 1. 4 and a 2. Again, the chances of making a mistake is very high, but I need to follow the work and see that it matches. And if I am to do this part, 2 times row 2. 2 times row 2 is actually 0, 4, negative 2, negative 4, 2, 0. Add it to row 1. Row 1 is 1, 0, 2, negative 2, 1, 0. Add those. That's a 1. That's a 4. That's a 0. That's a negative 6. That's a 3. That's a 0. And row 3, I'm just going to copy down. I'm almost done. One more step. If I make that a 0, but I must use those two. Of course, I could divide row 2 by 2 and row 1 by 4 if I want, but I'm not going to even go there. I'm going to think of an LCD. This is very unorganized. Yeah, I'm not liking this. Okay, let me take this work and let me put that work right there. And now the step goes right there. And now to make that a 0, if I let row 1 equal, and let's see how this works. LCD is 12. If I multiply row 2 by 2, row 1 by 3, make one of them negative, that will work. So what would happen then? If I multiply, and let me leave a bit of space, or even better, this higher, there we go, that will work. If I take negative 2 times row 2, 2 times row 2, that's 0, 12, 0, negative 20, 8, and a 4. Negative 3, negative 12, 0, 18, negative 9, and a 0. And add those, and that's a new row 1. Negative 3, 0, 0, negative 2, negative 1, and a 4. Now again, I might have made a mistake. You get the idea. This is a long process. And the last step, to make row 1 a 1, take row 1 divided by negative. Let row 1 equal divided by negative 3. And let row 2 equal, take row 2 divided by 6, and let row 3 equal row 3 divided by 3. If I divide row 1 by negative 3, I'll get a 1, 0, 0, 2/3, 1/3, and negative 4/3. Divide row 2 by 6. Divide by 2, divide by 2. And 0, 0, divide by 3. This is the inverse matrix of that matrix A. Now, you're gonna notice on the homework, the problems are gonna match. Whenever you find the inverse in one problem, so I'm gonna need this for the homework. When I get to the inverse matrix equation, I'm gonna need that right there, and I don't have to find it again. Same thing on your exam. The problems on your exam will match. That's the inverse of A. Done. So inverse takes a long time to find. And here's another one. I have one more for you. I want to find the inverse of this, and this time I'm going to work to the right, see if that's better. So, to find the inverse, I'm going to take 3, 2, 1, 3, 3, 2, 1, 0, 0. Write the identity matrix. And in my first step, I'm going to make this a 0 and this a 0. Well, how do you do that? To make the first a 0, the second, I'll let row 2 equal negative row 1 plus row 2. Well, what does that mean? Negative row 1, negative 3, negative 2, negative 1, negative 1, 0, 0. Row 2 is 3, 3, 2, 0, 1, 0. Add those. That is a 0. That is a 1. That is a 1. That's a negative 1, 1, and 0. So here I'm looking at row 2. 0, 1, 1, negative 1, 0. Row 1 I'm using, but I'm not changing. I want to make this a 0. So yeah, 1 above, 1 below will be perfect, I think. I'm going to take row 3 and let it be negative 3 row 3. That should be a 1, no? Negative 3 row 3 plus row 1. If I do this work, multiply row 3 by a negative 3. Well, row 3 by a negative 3, that's negative 3, 0, negative 3, 0, 0, negative 3. Add it to row 1. But put the result in row 3. 0, 2, negative 2, 1, 0, negative 3. Very good. Next step, make that a 0, using those two. And how do you do that? Well, here, I'm going to fit it right there. That will work. I'm going to let a row 3 equal negative 2 row 2 plus row 3. Okay, so row 1, not using nor changing. row 2 using but not changing. The only thing that's going to change is row 3, and the work will be right there. Multiply row 2 by a negative 2. That's 0, negative 2, negative 2, 2, negative 2, 0. Add it to row 3. Again, the chances of making a mistake is very high. It's going to take 4 steps for you to be done. That's 2 steps, 2 to go. The next step up is to make that a 0 and to make that a 0. To do that, I'm going to continue down here. Well, if I take, with the purple, if I take negative row 2 plus row 1, let that be row 1. That will do the trick for the first one. Right? So row 3, I'm not going to change. I'm going to change what I circled. The work is tedious, that's understandable. And if I let row 1 equal, and let's see, if I multiply row 2 by a negative 1, that's 0, negative 1, negative 1, 1, negative 1, 0. Add it to 3, 2, 1, 1, 0, 0. I'll get a 3, a 1, a 0, a 2, a negative 1, and a 0. And the green, if I let, again, I mean the blue, I want to make, oh, I switched them, didn't I? My mistake. So let this be 0, we did. Now we want to let this be 0. I can do the same thing. So what I could do, I could say, take row 4, take row 2, and let that equal 4 row 2 plus row 3. Makes sense? Multiply this by 4 and add it to that. That will work, but put the result in row 2. So, if I do that, I'm looking at that work is right there. Or maybe I should leave more space so I could fit both of those on. Again, I have all the space I need. So let me lower this a bit and maybe fit in there. I'm still trying to figure out how to do this nicely. So 4 times row 2, 0, 4, 4, negative 4, 4, 0. Add it to row 3, 0, 0, negative 4, 3, negative 2, negative 3. Add those. 0, 4, 0, 1, negative 1, I'm sorry, 2 and negative 3. One thing left. I need to make that a 0, and I must use that row. So if I take 4 times, negative 4 times row 1 plus row 2, put the result in row 1, that'll do it. Let's see how that plays. If I multiply row 1 by a negative 4, that's a negative 12, negative 4, 0, negative 8, 4 and a 0. Add it to row 2. I'll get a negative 12, a 0, a 0, a negative 9, a 6, and a negative 3. Row 2, I'm going to copy down. Now this beats, if you read the book, this really is a lot simpler than the way things work in the book. Now let row 1 equal row 1 divided by negative 12. Let row 2 equal row 2 divided by 4, and let row 3 equal row 3 divided by negative 4. So this will become what? That much work on every problem. Divide by a negative 12. Divide by a negative 12 by a negative 12 and by a negative 12 1/4. Divide by a 4 and divide by a negative 4 so the inverse matrix of A is actually 3 over 4, negative 1/2, 1/4, negative 1/4, negative 3/4, 1/2, 1/2, negative 3/4, and 3/4. Now, solve the system of equations by using matrix equations. What does that mean? Here, you don't have to do much work. Here, you have to write this as a matrix equation. So, if I was you, I would leave some space before 1, 2, 2, 5, matrix equation. Leave some space. Now, on your exam and the homework, if you look back at 1, 2, 2, 5, you'll notice you already found the inverse for that on the previous problem. And the inverse for that was, so, if you multiply on the left hand side by 5, negative 2, negative 2, 1. Now, even if you didn't do this problem, the inverse, even if you couldn't find the inverse, since we're using the inverse, you could say that's I2 on the left. That's all you have to do. And the identity times any matrix is the matrix. Here, 2 by 2, 2 by 1, isn't the outcome 2 by 1? So you have to multiply this. And that would be to generate the first row, use the first row. Well, 5 times 2 is 10 minus 6. And to generate the second row, use the second row, negative 4 plus 3. And that would be a 4, negative 1. So the solution to this problem is 4, negative 1. There it is. That's all you have to show me. You don't have to do any additional work. And if I take this problem, all what you have to do is write it out as a matrix equation. I would leave some space. 1, 0, 2, 2, 2, 3, 1, negative 1, 0. Write it as a matrix equation. That's a matrix equation. We did that on the last section. Leave space. And if you look at this vector right here, this matrix, we already found the inverse for that. The inverse for that is right there. 1, 0, 2. We got this mess. I know it's not pleasant. Most of the time it's not. That's okay. Since I know that's the inverse, if I multiply this side by that, okay, let me just switch this a bit to the right, a bit more. So all what you have to do, copy what's on the previous, whatever you got on the previous, in 2 places. As far as the left side, it's going to say on the exam, even if you didn't know how to find the inverse, use any matrix as the inverse. I just want to know that you know how to do this. This is the identity for a 3 by 3. And the identity times any matrix is the matrix. The right side, this is 3 by 3. This is 3 by 1. They match. So this is going to be 3 by 1. And to get the first, use the first multiplied by that. That is 2/3 plus 1 plus 4/3. To generate the second, you would use the second times this again. That is negative 5/3 plus 2 plus 1/3. And to generate the third, you use the third, negative 4/3 plus 1 plus 2/3. And that would be, what is that? 4/3 plus 6/3. That's 2 plus 1, that's 3. And here, you will have negative 5/3 plus negative 4/3 plus 2 all over 3. That's a 6. That's 2/3. And if you take negative 2/3 plus 2/3 is negative 2/3 plus 1, that's 1/3, which indicate the solution to this problem. And that's all you have to show me. And that's pretty much it. So, on your homework, it's going to match. And on the exam, it's going to give you a problem and write one problem, say find the inverse. The problem after that says use matrix equations to find the solution, meaning use inverses. Hence, look at the previous problem. If you were not able to solve the previous problem, write any matrix as the inverse. I just want to know that you know how to do this process. And that would be it for this section.